Next, we will move on to a talk by Tim Horvath, who will discuss mission constraints and relevant resources for Artemis science exploration.
Good morning, everyone. My name is Tim Horvath, and I work in the Artemis Campaign Development Division, ACD, in the Mission Development and Utilization Office, and I'm the ACD Deputy Lead for Utilization. So I appreciate you having me here and the opportunity to present. Today I'm going to talk a little bit about the Artemis architecture and some of its capabilities and constraints. And please note that this is not just a focus on Artemis 3, but it's going to be looking across the entire Artemis effort. Next chart, please. Okay, so what is Artemis? Artemis is more than just the collection of the NASA divisions and programs that are building the hardware that are going to take us back to the moon. It's about making new and important scientific discoveries. You've already heard Dr. Lawrence talk about that. That's the emphasis of this workshop. Artemis is also about establishing a long-term presence on and around the moon. It's about learning how to live on other planets, and it's about putting the first woman and first person of color on the lunar surface so we can inspire the next generation of explorers. Next chart, please. Okay, a little bit more about the Artemis architecture. It's a mix of traditional NASA programs as well as commercial partnership strategies working with the US industry. It's going to take many different programs and elements and vehicles to make up the full Artemis architecture as we move forward to enable a long-term lunar presence. Exploration ground systems, those are the capabilities we need to get our vehicles and rockets ready to fly and for their recovery at the end of the missions. Our space launch system used to launch the crew on the Orion spacecraft and bring additional modules and capabilities to the Gateway Space Station. Orion is the crew's transit to and from cislunar space, and currently is the only capability we have to return science samples from the moon that the astronauts will be working to get. We have our space communications and navigation, which enable the voice, imagery, and data to and from the moon and cislunar space. And then, of course, the human landing system, which will take the astronauts to and from the lunar surface. I will have more details on HLS later in my presentation. Surface operations, surface mobility, the EVA spacesuits, all those are key to what we're doing on the surface of the moon to accomplish scientific programs and sustain our presence on the lunar surface. Again, I've got more on this a little bit later as well. And then finally, Artemis Base Camp to allow a buildup of capability and equipment that we can use more than one time for more than one mission. Next chart, please. All right, we call this the Artemis 3 mission map, and it's a lot of fine print, and I'm definitely not going to read it all to you. Really, the key point to take away from this is that we are designing Artemis for the long term. Artemis 3, we know it's HLS and Orion are the two key pieces of that, but the architecture is all about developing a system that enables us access to the lunar South Pole so that we can start a campaign to establish that lunar presence. So in our mission design, we need to make sure we're both accomplishing the scientific objectives for the mission, as well as any objectives that we need to allow us to think strategically about what that looks like long term. Next chart, please. A little bit more about the human landing system. The Human Landing System program is a good example of NASA using a commercial partnership with US industry. SpaceX has been awarded the contract for 2 missions. There will be an uncrewed lunar demo mission, which will prove the capability to land on the lunar surface. And that'll be followed by a crewed lunar mission, Artemis 3, putting the first 2 Americans on the lunar surface for the first time since Apollo 17. Next chart, please. In case you haven't seen it, I'm sure most of you have. SpaceX's Starship is the vehicle that we're expecting to perform these 2 missions. It's a very large spacecraft, and to help you visualize the scale, That image on the left side has a couple of astronauts at the very bottom of the image next to the landing struts. Starship is going to have a crew and cargo elevator to move the astronauts and equipment up and down. There's going to be an airlock, obviously, to enable the egress and ingress, and is going to have a cabin for the crew to stay in. Next chart, please. It's important to remember, though, once we get beyond Artemis 3, SpaceX will not be the only provider of a landing system. The HLS program is set up to allow for other contracts that will enable other providers to provide lunar landing services to the program and to Artemis. Next chart. So last fall, 5 providers were selected to develop their design concepts and help mature their strategies, and then use their corporate innovation to come up with new solutions for lunar landing capabilities. The RFPs are made publicly available, so if you're interested in what the requirements were that were the basis for some of these companies' strategies, those RFPs are out for public review, and that's what the companies are using as a basis for their designs. Of course, we don't know exactly what additional capabilities their vehicles might have. That's the part of the strategy, is to allow them to innovate what their capabilities might be. Next chart, please. Okay, the spacesuits we'll use on the moon, again, also part of a commercial partnership strategy. The EVA and Human Surface Mobility Program has just selected 2 vendors to build the next generation of EVA hardware. Axiom Space and Collins Aerospace, mentioned at the bottom of that chart, are the 2 companies that were selected. Next chart, please. It's important to note that the contract includes both the suits themselves, as well as the interfaces to the vehicles and all the support equipment, and most importantly to this forum, the geology equipment for sample collection and the sample containers and the things that we're going to use on the surface of the moon. Next chart, please. Okay, the Lunar Terrain Vehicle, again, not applicable to Artemis 3, but it will be in later Artemis missions. Also known as the rover, it'll be designed for both human use to extend the area the crew can explore, as well as autonomous or remote operations when the crew are not on the surface. Next chart, please. LTV will provide the capability for multiple missions. It'll be able to move from landing site to landing site between missions. It's going to have capability for science instruments and be able to deploy lunar assets. So the requirements definition for this vehicle are in work, and we are expecting the RFPs to be out probably in the late summer, early fall timeframe. So again, RFPs will be out and available publicly. If you're interested in the requirements that these vehicles are going to be designed as their starting point, you're welcome to look those up when they get released. Next chart, please. So in closing, I wanted to mention the Artemis Campaign Development Division role in Artemis. We're responsible for the mission definition and mission integration across all the elements and teams that make up Artemis. A critical piece of our success, of course, is going to be integrating utilization into all aspects of these missions, ensuring we accomplish science in the near term, as well as enabling us to build a long-term presence. Artemis 3 comparatively may be starting small with only a couple of vehicles, and we'll need to be as efficient as we possibly can in the early missions as we learn. But the goal is to increase capabilities over time with an eye towards future exploration. Next chart. Okay. And this is my last slide, so I appreciate your attention, and thank you very much for having me here.